how multi-level paging is achieved in operating system. From our earlier understanding about the page table, we know that for translating any logical address or virtual address to the physical address, we need a page table which will simply translate virtual address to the actual physical address or absolute address. And this page table contains so many entries, and each entry will map a particular page of virtual address memory to the frames of main memory. And here I am considering each frame size is 4 KB. And one question here, where this page table is stored? Is it in secondary memory or is it in main memory? The answer is it is stored in main memory. And what is the size of this frame? And we know that every frame size is 4 KB only. So this page table we have to store in 4 KB size. And what if page table size itself go higher than the 4 KB? Let's say this page table size is 8 KB. Can we store this page table in that case? The answer will be no. We have to split this page table in 2 frames, right? Now you got the issue with normal paging technique. Let's deep dive and understand about multi-level paging concept, and we will understand this with 2-level paging. Here this main memory is divided among multiple frames. I have not considered OS space here. Let space for operating system is already allocated and kept aside, and the remaining space is divided among 4 KB frames. So here we have multiple frames and each frame size is 4 KB. So how many memories we can address this in a single frame? So we can access 4096 memories that we can address with 12-bit. 2 to the power 12 equals to 4096. So we can address memory in a single frame with 12-bit address. So I am removing here 12-bit from this 32-bit. I have considered this main memory can be addressed with 32-bit. So just removing 12-bit from here and we will be left with only 20 bits, and this 20 bit will be used to address different frames here because we are having so many frames. And what will be the number of frames here? It will be 2 to the power 20. So simple, we have 2 to the power 20 frames, and to get the exact memory address we can access that with 12 bits. So this will tell you the displacement or offset in a particular frame. Let's suppose you have selected this frame using this 20 bit, and this 12 bit will tell you which offset you have to access in this frame. Okay, till now it is clear. 12 bit is for offset and 20 bit for frames. Now you have to address, or I say you have to keep entries for how many frames in this page table? You have to keep entry for 2 to the power 20 frames, right? Because this page table maps page to the frame, so it will keep entry for 2 to the power 20 frames. And let's suppose your each entry is having size of 4 bytes, correct? Your each entry having size of 4 bytes. So in a single frame, because you have to keep this page table somewhere in the main memory in many frames, so I'm just calculating in one frame how many entries you can keep. As the size of each frame is 4 KB and one entry size is 4 bytes, so you can store 1 KB entry in a single frame. Clear? Okay, so now how many such frames you need to store entire page table? As you have to store 2 to the power 20 frames and you are keeping information of 1 KB frames in a single frame, so you need 2 to the power 20 divided by 2 to the power 10. 2 to the power 10 is nothing but 1 KB. 1 KB equals to 2 to the power 10. So you need 2 to the power 10 frames to store this page table. You might have confused here. Just go back and listen for one more time. You will understand it. So we need 2 to the power 10 frames to store the entire page table. So okay, so this page table is stored in the main memory, That is fine. But how CPU will come to know in which frame the actual frame information is present that he is interested for? Let's say CPU is interested for this frame whose information is stored in some page table in some frame of this page table. So CPU has to iterate over the entire page table, or in another words, it has to iterate starting to the end frame where this page table is stored to get the exact frame information of the physical memory. So to solve this problem, a very interesting approach were proposed. What was that approach? The approach was you just store the information of these frames where this page table is stored. You just store the information of these page table frames into another page table. Let's say this page table 1, which is keeping the information of page table frames. So how many entries it has to keep? It has to keep 2 to the power 10 entries. And for that, how many bytes it requires? Because each entry will hold 4 bytes, so it requires 2 to the power 10, that many page table frames it has to store, 2 to the power 10 into 4 bytes, which is nothing but 4 KB. 2 to the power 10 is 1 KB and each entry size is 4 bytes. So this page table size will be 4 KB. And can we store this page table in a single frame whose size is 4 KB? The answer is yes, because our frame size is 4 KB and this page table size is also 4 KB. So we can store in a single frame. So how CPU will access here? CPU will first come to this outer page table, and from this outer page table it will get the information of page table frames, and once it gets the information of page table frame, it will go to that particular page table frame, and from there it will get the actual frame information. So with the help of outer page table and inner page table, we can access the absolute physical memory. Don't get confused here by thinking this is stored in single frame. Basically this is stored in multiple frames. 2 to the power 10 frames it will be stored. So now this outer page table will tell you which frame you have to access out of 2 to the power 10 frames. So you have to select one out of 2 to the power 10 frame, and from there you have to get the actual frame address. Now let's go one step further. So this is 32-bit. This 12-bit will give you the displacement or the offset in the exact frame, and this 20-bit will give you the information about the frame. So just splitting this 20-bit to 10 bits, the MSB 10-bit will give you the displacement in the outer page table. And where the address of outer page table will be stored? It will be stored in page table base address register. So by accessing this register, CPU will come to know where the outer page table is stored in the main memory. And once it gets the page address, so it will go there, and with the help of this 10-bit, it will go to the exact offset value in that outer page table, and it will collect the entry at that offset and come to know the address of the frame, or you can say the base address of the frame where the page table is stored. So out of 2 to the power 10, it has to select one frame. So basically that information will be given by this outer page table. And now with the help of next 10-bit information, you have to traverse in that frame and you have to get the exact entry for that. And now you will be having exact frame address. This frame address you will get now, and in that frame now you have to traverse. For that you need offset, and from where you can collect this offset value? You can collect from this 12-bit, and that's how you can access the exact physical memory here. Or in other words, from logical address you can get the information of actual physical address with this multi-level paging concept. Here 2-level paging were used. Similarly, you can have translation for 3-level paging also. Here level 1, level 2, level 3 will be having for frame address information, and this offset will tell you the displacement in that frame. This level 1 will tell you the displacement in the outer page table, and this page table base address register will tell you the outer page table base address, and by going there you have to traverse in this frame, and once you get the information of next frame, so you will go to that frame, and with the help of this level 2 address you have to again traverse in that frame, and then you will get the exact frame information base address, and once you get the frame information you come to that frame and traverse again in this frame till this offset and get the actual or exact physical address. So this was the small concept about multi-level paging technique in operating system. I hope you would have understood this concept, and let me know if you have still any doubt regarding this paging technique or multi-level paging technique. Thank you so much for watching this video, and I'll see you soon.